Under laws of chemical combinations, now we will study the fifth law, which is Avogadro's law. In 1811, Avogadro proposed that equal volumes of all gases at the same temperature and pressure should contain equal number of molecules. Here, equal volumes and at the same temperature and pressure. These two terms are very important. Why? If gases under observations are not at same temperature and pressure, then their volume will not remain equal. By changing temperature and pressure, volume of gas will change. If volume of gas will not remain same, then they do not contain equal number of molecules. Now consider the reaction of hydrogen and oxygen to form water vapor. Hydrogen gas plus oxygen gas, you are getting water vapor. This is water vapor. First you have to balance it. Here two oxygens are there, one oxygen atom is there, so you have to make it here 2, and here you have to make 2 2s are 4, means here 2. So from this reaction you can say 2 volumes of hydrogen is reacting with 1 volume of oxygen to produce 2 volumes of water vapor. Out of these 2 volumes of hydrogen gas, if we are keeping 1 volume hydrogen here, another volume of hydrogen gas here, and this 1 volume of oxygen we are keeping here, and out of these 2 volumes of water vapor, 1 volume of water vapor we are keeping here, another volume of water vapor we are keeping here. So everywhere volume of gas is same. So according to Avogadro's law, if these are at same temperature and pressure, these have equal number of molecules. But these molecules have different size and mass, because size of one molecule of hydrogen is different from size of one molecule of oxygen, and also it is different from one molecule of water vapor. Now suppose we are having all these gases at same temperature and pressure, at same temperature and pressure. Okay, then 50 ml, it is having n molecules, n number of molecules. Then 50 ml of hydrogen gas will also contain n number of molecules. Then 100 ml of sulfur dioxide gas will contain 50, 100, so it's just double. So it will contain 2n number of molecules, and 25 ml of carbon dioxide gas will contain, you just compare it with 50. 50 ml is having n molecules. According to Avogadro's law, 50 ml of carbon dioxide will also contain n molecules, but 25 ml of carbon dioxide will contain n by 2 number of molecules. Now the topic laws of chemical combinations is completed here. If you like this video, please like, share and subscribe to my channel. Thank you. In this video I am going to explain atomic mass, average atomic mass, gram atomic mass, molecular mass, gram molecular mass, and we will solve some problems. What is atomic mass? The mass of an atom is called atomic mass. The mass of an atom is very small, so it's not possible to isolate an atom and weigh it. Nowadays we have sophisticated techniques, that is mass spectrometry. For the determination of atomic mass almost accurately. Mass of an atom of hydrogen is equal to 1.6736 into 10 to the power minus 24 gram. So it is in the order of 10 to the power minus 24 gram. So how much small it is, you can understand. Therefore, mass of an atom is so small that gram is very big unit to express it. In order to solve this problem, in the 19th century, scientists determined the mass of an atom, of an element, relative to another. Since hydrogen is the lightest element in the periodic table, in the beginning it was chosen as a standard element and other elements were assigned masses relative to it. The present system of atomic mass is based on carbon 12. You can write like that way also. As the standard, carbon 12 is one of the isotopes of carbon and its abundance is 98.892%. Although carbon 13, carbon 14 isotopes are also known, but their relative abundance is negligible. On the carbon standard, relative atomic mass of an element is equal to mass of one atom of an element divided by 1/12 the mass of one atom of carbon 12. An atom of carbon 12 isotope has a mass of exactly 12 AMU. AMU means atomic mass unit. So if 12 AMU is the mass of one carbon 12 isotope, then 1 AMU is equal to 1 AMU is equal to 1/12 of the mass of one carbon 12 atom. Is it clear? If 12 AMU is the mass of one carbon 12 at isotope, then 1 AMU is equal to 1/12 of the mass of one carbon 12 atom. One AMU is equal to one atomic mass unit is equal to 1.66056 into 10 to the power minus 24 gram. This is very important. You have to remember this thing. Okay. At present, AMU has been replaced by U. U means unified mass. So how we are getting this value from here? The mass of carbon 12 atom was determined by mass spectrometer and this value is 1.992648 into 10 to the power minus 23 gram. Therefore, 1 AMU is equal to 1/12 into this one, because mass of one carbon 12 atom is this. So 1/12 of that this much gram. So if you calculate, you will get this value. Clear? Now we will calculate mass of one hydrogen atom in atomic mass unit. You know, one hydrogen we can represent like that way. One hydrogen atom is this one. This is atomic number and this is mass number. This is atomic number and this is mass number. So atomic number gives number of proton in the nucleus of that atom. So here number of proton is 1. Since an atom is electrically neutral, so number of electron outside the nucleus also it is 1. And mass number means atomic mass or mass number is equal to number of proton plus neutron. So since it is 1, so proton already it is 1 and neutron number is 0. Like that way it is coming 1. So we can write therefore mass of one atom of hydrogen is equal to mass of one proton, because electron is also there, one electron is there, but it's having mass negligible. Its mass is negligible. So mass of one proton is 1.6736 into 10 to the power minus 24 gram. From this relation, we can write 1.66056 into 10 to the power minus 24 gram corresponds to 1 mu. Therefore, 1 gram means 1 by 1.66056 into 10 to the power minus 24 gram, and it is given this much gram. Therefore 1.6736 into 10 to the power minus 24 gram means this much gram divided by 1.66056 into 10 to the power minus 24 gram into, this is AMU, 1 AMU. So gram, these are cancelled, and if you calculate, you will get this value as almost approximately 1.0080 AMU. So mass of one hydrogen atom in atomic mass unit is this. Our next topic is average atomic mass. So first we should know why do we need to study average atomic mass. For that we should know what are isotopes. So you know already that isotopes are the different atoms of the same element with different mass number and same atomic numbers. As for example, these three are isotopes of carbon. Carbon 12, carbon 13 and carbon 14. These three are having same atomic number but different mass number or atomic mass. Many naturally occurring elements exist as isotopes. In such cases, we need to find out average atomic mass. If someone will ask you what's the atomic mass of carbon, then you have to answer its average atomic mass. But what's the atomic mass of carbon 12? Then answer is 12. Is it clear? Now, if A and B are the atomic masses of two isotopes of an element, then and X and Y are ratios in which this isotope exists, then average atomic mass will be AX plus BY divided by X plus Y. Using this formula, you can find out average atomic mass of that element. Now we will solve some problems. Number 1. If chlorine has two isotopes, chlorine 35, chlorine 37, and their relative proportions are 3:1, then find out average atomic mass of chlorine. So here you can write whatever formula I gave, that is average atomic mass is equal to AX plus BY divided by X plus Y. Here A is equal to what? 35. B is equal to 37. X is equal to 3. Y is equal to 1. So using that formula we can write 35 AX 35 into 3 plus BY 37 into 1 divided by X plus Y means 3 plus 1. So we can write 105 plus 37 divided by 4. So it is coming 142 divided by 2. Divided by 4. So answer is 35.5 U, unified mass, or AMU you can write. Element boron has these two isotopes, stable isotopes B10 and B11, and percentage of abundance is 20%, 80%. Find out average atomic mass of boron. So here also how you will solve the problem? Average atomic mass of boron. Here A is equal to 10, B is equal to 11, X is equal to 20, Y is equal to 80. So using the formula AX plus BY divided by X plus Y, we can write AX. So 10 into 20, BY means 11 into 80 divided by X plus Y, 20 plus 80. So it is coming 200. This is 880 divided by 100. So we are getting 10.8 U or AMU. Next problem. Two isotopes of copper are this and this, copper 63 and copper 65. The average atomic mass of copper is 63.5. Calculate the percentage abundance of each isotope. So what is given here? Isotopes of copper, isotopes of copper. One is this and another is this one, 65, and previous one is 63 copper. Now percentage of abundance, let this is x%. So if total is 100, then it will be 100 minus x. If it is not given percentage abundance, then you can think like that way. Okay. Therefore, average atomic mass of copper is equal to, same formula, ax plus by divided by x plus y. So here you can write 63 into x plus 65 into 100 minus x divided by x plus y, totally it is 100. So average atomic mass is given already and it is 63.5. If you solve this one, you will get then write 6350. So this is coming 150. Therefore x is equal to 150 divided by 2. So it's coming 75. Therefore percentage abundance, therefore percentage abundance of copper 63 is what? 75%, and copper 65 is 100 minus 75 means 25%. This is your answer. Next topic is gram atomic mass. It is gram atomic mass expressed in gram. Actual mass and gram atomic mass are different. For example, for hydrogen, actual mass is 1.6736 into 10 to the power minus 24 gram. You know already this thing. And atomic mass is 1.008 unified mass, U or A mu. And gram atomic mass is same thing, only unit is different, it is gram. Okay. Now how you will get gram atomic mass? We will see some examples. Now first example, we will calculate gram atomic mass of oxygen 16 isotope. Okay. So this isotope of oxygen, it is having 8 atomic number and 16 mass number or atomic mass. That means in the nucleus of this atom, it is having 8 protons and 8 neutrons. 16 minus 8 is equal to 8. And to make the atom electrically neutral, outside the nucleus, 8 electrons are revolving. But you know, mass of 8 electrons or mass of electrons are very, very small. So you can neglect mass of electron. So mass of one atom of oxygen means mass of 8 protons plus mass of 8 neutrons. Mass of electron we are neglecting. And since mass of proton and mass of neutron for calculation we are considering it is equal, so we can write this one 16 mass of proton, and mass of each proton is what? 1.67 approximately into 10 to the power minus 24 gram. So mass of one atom is this much. Therefore mass of Avogadro number of atoms, we can write Avogadro number as Na, number of this atom, these atoms is equal to 16 into 1.67 into 10 to the power minus 24 into Avogadro number. What is Avogadro number? 6.022 into 10 to the power 23. So if you calculate from this part, we will get 1. So 16 into 1 means it is 16 and this is gram. So 16 gram we are getting. And this is your gram atomic mass of oxygen. So atomic mass of oxygen is 16 AMU or 16 U, and gram atomic mass is same number 16 with unit gram. Next example, mass of one atom of nitrogen, this isotope, here this is atomic number, this is mass number 714. So in the nucleus 7 protons are there and 7 neutrons are there. Outside the nucleus whatever electrons are there, 7 electrons are there, but we are neglecting the mass of electron. So we can write mass of one atom of nitrogen is equal to 7 into mass of proton plus 7 into mass of neutron. Since mass of proton and mass of neutron are almost equal, so we can write 14 mass of proton. Same thing like previous one, 14 into mass of proton means 1.67 into 10 to the power minus 24. Then therefore mass of Avogadro number of nitrogen atom is equal to 14 into 1.67 into 10 to the power minus 24 into Avogadro number 6.022 into 10 to the power 23. Once again this part is coming 1, so 14 into 1 it is coming 14 gram. Atomic mass of nitrogen is 14 U or 14 AMU and gram atomic mass is 14 gram. You have to give unit as gram. Next topic is molecular mass. What is molecular mass? Molecular mass is the sum of the atomic mass of the elements present in a molecule. Now as for example, methane, we are considering methane. So to calculate molecular mass, what we have to do? We know atomic mass of carbon is what? 12.011 U. Atomic mass of each hydrogen is 1.008. 4 hydrogen atoms are there. So 4 into this is U. So molecular mass is the sum of the atomic mass of the elements present in a molecule. So this is atomic mass of this carbon and atomic mass of each hydrogen is 1.008. 4 hydrogen atoms are there, so you have to multiply 1.008 with 4, and if you calculate, it is coming 12.011 plus 4.032 U. After calculation, it is coming this. But for numerical problem, for most of the elements, we are considering the whole number value of the atomic mass. For example, oxygen, for oxygen 16, we are getting this is as atomic mass is 15.995 U, but for calculation we can consider this one as 16 U atomic mass. Okay. So next example I am giving, calculate molecular mass of HNO3. What is HNO3? Nitric acid. So each hydrogen is having atomic mass 1. One hydrogen atom is there. So 1 plus nitrogen is having atomic mass 14. Each oxygen we are considering 16. So 3 into 16. So if you calculate, it is coming 15 plus 48, 63 U. Next topic is gram molecular mass. What is it is? It is molecular mass expressed in gram. It is also called molar mass. Gram molecular mass of every substance consists of Avogadro number of molecules. Now you see, if we want to calculate molecular mass of oxygen. So oxygen atom is having atomic mass 16 unit. So in molecule, oxygen molecule 2 atoms are there. So 16 to the 32. Its molecular mass is 32 unit. So if you convert it in gram, it is coming 32 into 1.67 into 10 to the power minus 24 gram. Each oxygen atom is having atomic mass 16 unit because in the nucleus it is having 8 proton and 8 neutron. So 8 plus 8 means 16 mass of proton. Each mass of proton means 1.67 into 10 to the power minus 24, and in oxygen molecule 2 oxygen atoms are there, so it is coming 32 into this much. Clear? And mass of Avogadro number of molecules of oxygen is this one. You have to multiply it with Avogadro number. Similarly, like previously we have done, this part is coming 1, so it is 32 gram. So molecular mass of oxygen is coming 32 unit, and gram molecular mass or molar mass, it is coming 32 gram. Let's try some problems. Number 1. In 3.2 gram of oxygen gas, find out the number of molecules. Now see, in one oxygen atom, in the nucleus, there is 8 proton and 8 neutron. And outside the nucleus, 8 electrons are revolving. So, since mass of electron is negligible, so we can consider that mass of one oxygen atom is mass of 8 proton plus mass of 8 neutrons. Since mass of proton and mass of neutron are approximately same, so we can consider this as mass of 16 proton. So here 16 into mass of 1 proton, you can write 1.67 into 10 to the power minus 24 gram. So approximately this is equal to 16 atomic mass unit. And in oxygen gas, 2 oxygen atoms are there. So here we can write molecular mass of oxygen gas is 16 into 2 is equal to 32 AMU. And you know, we have studied already, gram molecular mass of oxygen is 32 gram. In 32 gram of oxygen, number of molecules present, you know, is Avogadro number 6.022 into 10 to the power 23. Therefore, 1 gram of oxygen atom in this number of molecules present is equal to 6.022 into 10 to the power 23 by 32. And whatever given it is 3.2. In 3.2 gram of oxygen number of molecules present is equal to 6.022 into 10 to the power 23 into 3.2 divided by 32. So here we can make this. This is your answer. This number of molecules are present in 3.2 gram of oxygen. Next problem, calculate the number of atoms and number of molecules present in 2 gram of nitrogen. So first is number of atoms. So you know, gram atomic mass of nitrogen is 14 gram. Therefore, we can say number of atoms present in 14 gram of nitrogen is Avogadro number, means 6.022 into 10 to the power 23. Therefore, number of atom present in 1 gram of nitrogen is this, and it is given 2 gram. Present in 2 gram of nitrogen is this much. Means you can write this is Avogadro number divided by 7. Number 2, gram molecular mass of nitrogen is 14 to the 28 gram. Gram molecular mass means in it how many molecules are there? Avogadro number. So therefore, number of molecules present in 28 gram of nitrogen is, I am writing here, Avogadro number. Therefore, number of molecules present in 1 gram nitrogen is equal to Na by 28, and it is given in 2 gram. Avogadro number by 14. This much molecules are present. In place of Na, you can write this number 6.022 into 10 to the power 23. This much, this number of molecules. Okay, and here this number of atoms. Here it is molecules. Next problem. Find out the mass of 10 to the power 20 atoms of magnesium. It is given atomic mass of magnesium is 24. Therefore, gram atomic mass is 24 gram. That means that mass of Avogadro number of atoms of magnesium is equal to 24 gram. Therefore, mass of one atom of magnesium is 24 divided by Avogadro number, and it is given 10 to the power 20 mass of 10 to the power 20 atoms of magnesium is equal to 24 into 10 to the power 20 divided by 6.022 into 10 to the power 23. So approximately in place of this we can write 6, and we will get this, and here 10 to the power 20 minus 23 means minus 3, this much gram. Then here 6 4s are 24, 4 into this means 0.004 gram.